Yeah, good morning, students. Today's topic for discussion is controlling IO device behavior. Now, I would like to share my screen. So, today's classroom discussion topic is on controlling IO device behavior. The lecture objectives are: this session will develop students' knowledge on controlling IO device behavior by making use of processor registers. Controlling IO device behavior. So, we need a mechanism in the interface circuits of individual devices to control whether a device is allowed to interrupt the processor or not. So for that particular purpose, the control unit needed is usually provided in the form of an interrupt enabled bit in the device interface circuit. So a commonly used approach is to provide a control register in the device interface. We are providing a control register in the device interface. So which holds the information needed to control the behavior of a device. So this control register is accessed as an addressable location. So one bit in this register serves as the interrupt enable bit, i.e. we are calling it as. So when this bit is set to 1, that indicates that we are going to raise an interrupt. That means the device is generating an interrupt, so that which allows that device to generate an interrupt the processor whenever it is ready for transfer of an IO. So these are the processor control registers. So PS, in that 32-bit register it is a, and we are taking a interrupt enable bit we are taking here, and this is another register IPS. Okay, I enable, this is another processor control register. This is I pending. These are the four important processor control registers, so which are used for making use of this interrupt servicing, generating an interrupt, enabling of that interrupts that we can do. Okay, so whether it is a keyboard or whether it is a display, whether it is a timer interrupt, okay, whether it is the interrupt generated by the display device or whether it is the interrupt generated by the keyboard, which is a standard input device. So like that, here we can make use of these processor registers as a control registers for making use of processor control mechanism for generating of these interrupts. So the status register PS, which includes the interrupt enable bit IE in addition to other status information. So recall that the processor will accept interrupts only when this IE bit is set to 1. So the IPS register is used to automatically save the contents of PS when an interrupt request is received and accepted by the processor. So when the processor accepts and receives an interrupt, then the contents of PS is going to be saved in IPS register. At the end of the interrupt service routine, the previous state of the processor is automatically restored by transferring the contents of IPS into PS register. So this is a reflection point 1. So what is the role of PS register? Any student can answer this question. Now coming to this processor control registers, since there is only one register available for storing the previous status information, it becomes necessary to save the contents of IPS on the stack if nested interrupts are allowed. So the I enable register allows the processor to selectively respond to individual IO devices. So this is the purpose of I enable register. So that means whenever we have a multiple interrupts generated by multiple IO devices, so based on the I enable register, which allows the processor to selectively respond to the individual IO devices. So when a bit is set to 1, the processor will accept interrupt request from the corresponding device. Similarly, the I pending register indicates that the active interrupt requests. So what are the active interrupt requests that are in pending state that will be stored in the I pending register. So this is convenient when multiple devices may raise requests at the same time. Then a program can decide which interrupt should be serviced first. Fine. So this is what about the lecture level practice problem. So what is the role of I enable and I pending registers in handling IO requests? So after listening to this video lecture, so you should able to perform controlling of IO devices behavior by processor control registers. Okay, so thank you one and all for your patient listening for this video. Thank you.